Testing the Effects of Alcohol on Crickets by Scanlin and Kushnieruk. Question: how do substances alter the living organism's behaviors and create preferences that eventually lead to addiction? Hypothesis: if you give a group of 15 crickets the choice between water and a beer sugar solution, they will choose the beer sugar solution.
Abstract. All types of substances, no matter the dosage or potency, can have a variety of effects on those who use them. When taken, substances such as alcohol, severe stimulants, opioids, and even over the counter pills increase endorphin production within their users' minds. Endorphins are produced by the brain and they activate the body's opiate receptors, which control pain severity and expression in the body. So the activation of these receptors ends up leading to pain relief. Additionally, preferences towards specific substances created by endorphin production often end up leading to addiction. Our research paper and experiment focused on the following subtopics: neurological effects of addiction, genetics and addiction, types of addiction, mechanism behind addiction, health consequences of addiction, mental health coinciding with addiction, and withdrawal symptoms. Experiment. Our experiment will consist of observing the behavioral and active differences between a control and experimental group of 15 crickets. 15 crickets in each group, so 30 in total. First, we'll spend a week observing the behaviors and differences between the control group and experimental group without giving the experimental side any amount of alcohol. Then, after the week is up, the experimental group's water will be soaked in a sugar beer solution before being given to the crickets. The experimental group will then eat this soaked mixture every day for 2 weeks. We'll observe differences in the two groups' behaviors, birth rates, and death rates, also eating and drinking rates. Once the 2 weeks are up, we'll add a source of normal water to the experimental group enclosure, therefore giving them the choice between the beer sugar mixture and the water. The independent variable is the type of water solution, the dependent variable is the cricket behaviors, and the control variables are the duration of the experiment and the amount of crickets in each group.
Specifications: 15 crickets were placed in each enclosure. Cricket food was replenished as needed, but it isn't mandatory as the cricket's water doubles as a food source. Beer was used during the experiment, specifically Corona, which is 5% alcohol. The crickets were given a new bowl of solution every 3 days. The beer sugar solution was consisted of 2 ounces of cricket water, 4 ounces of Corona, and 1 ounce of sugar. The crickets solution was soaked in the Corona sugar mixture for about 10 minutes. Um, 30 minutes after the beer sugar solution was replenished, the crickets were observed for a period of 20 minutes. We have week one testing, March 24th through March 31st. The experimental began with 15 crickets. Crickets ate 2 to 5 other crickets during this week. By the end of the week, the crickets had laid eggs and multiplied due between 25 and 27. Control, they also began with 15 crickets. They were a little more mellow and didn't really eat each other. Uh, the crickets ate almost all of their food, and by the end of the week, the crickets had laid eggs and multiplied to 25.
Week 2 and 3 testing. This is the experimental side. This was from April 1st to April 15th. The major observations here were this week began with 25 to 27 crickets. The crickets avoided the hydration pellets for a day or two and ate very little of the food for both weeks 2 and 3. Two crickets that died during the week turned a very dark color, we think most likely due to alcohol poisoning, and then the other crickets didn't eat the ones that turned dark, but they did eat all the other ones. The population was reduced to 12 by the end of week 3, and the cages smelled absolutely terrible. Also, the crickets in the experimental side by the end of this period were larger than the ones on the control side. Weeks 2 and 3 testing control. This is also April 1st through April 15th. Week 2 in control began with 25 crickets. Major observation was that they began to eat each other and they ate almost all of the food and water both weeks, which unlike the experimental group who didn't eat almost like any of their water or food. By the end of week 3, the control population was reduced to 11 and the cage was littered with droppings and dead.
We have week four testing, experimental. So in week four, they had 12 crickets in the experimental stage. Um, for behavior, the crickets were weary of both of the hydration pellet stations. And in the experimental side, they were slightly slower. Um, they were kind of staying away of the experimental side, and we believe that because of the hydration poisoning and all of the crickets that had died before them. For the observation, um, by the end of week four, there was one big cricket alive, and he had seemed to be drinking mostly from the alcohol sugar pellet station. and it was just very odd. And the crickets that had died had become very dark colored. Now we have week 4 testing control. There was 11 crickets left. The crickets on this side continued to eat each other, and they didn't seem like as dark or as poisoned when they had died. Um, and then observations, they had reduced to 2 by the end of the week, um, and none of them were really of that darker color.
So here are our tables. In the population rate, you can see they rose and fell pretty similarly. And then as for eating rates, they were similar in the first week, and then in weeks 2 and 3, the experimental side actually dropped significantly compared to the control side. As for drinking rates, it's pretty similar to eating rates. You can see in week 1, they were around that same mark, around 90. And then weeks 2 and 3, experiment fell to 75, control stayed at 95. And then really significant change in week 4 as experiment dropped to 35 and control stayed at 85. So here are graphs for eating and drinking rates. Experimentally, you can see kind of fell similarly, and then eating and drinking rate stayed around that 80 to 100 range. And then as for population rate, they actually almost fell identically.
So, analysis. The data suggests that the crickets did not have a clear preference from alcohol over water. Although the crickets in the experiment group drank more of the alcohol mixture in weeks 2 and 3 compared to the normal water in week 1, by week 4 they were given the choice and they did not specify or consume either one. Um, Despite the inability to confirm addiction, the experiment confirmed that alcohol consumption negatively impacts the cricket's health and behavior, causing symptoms such as falling, disorientation, reduced activity, rancid odor, and high mortality, which was not observed in the control group. The experimental group did not yield clear results as expected due to the limited observation time and the cricket's short lifespan. More extensive observation might have provided clearer conclusions.
In conclusion, our experiment did not support the hypothesis that after both the sugar alcohol mixture and regular water were placed in the experimental group's enclosure, the crickets would voluntarily choose the sugar alcohol mixture. Our overall experiment was to observe the behavioral and active differences between a control and experimental group of crickets, and throughout the testing process of this experiment, our major learning point was that not all of your data is going to show what you thought it would, and that's part of science, and most hypotheses aren't always correct. When comparing our data to the data of similar experience, or experiments which use Drosophila flies, we found that both crickets and flies slightly lose their balance, speed, coordination, and response time when under the influence of alcohol. Ultimately, our data points to the idea that alcohol does alter almost every behavior within crickets, but is also extremely dangerous and mostly fatal in high doses. Anyone who wants to repeat an experiment like this, or even our experiment, should be really careful with how much alcohol they give the crickets. If we were to change anything about our experiment, we would want more time to observe the crickets, and we should have spent more time observing them, but we just never found the time after school. And lastly, because the crickets ate each other, we were not able to get a full death count or birth count. And here's our works cited page. Thank
Thank you.
you.